Now our next topic is what? Electric power. What in class 9 I think we have done. And what is power? Power is nothing but the rate of doing work. When I say rate, what is the meaning of this? That will divide the quantity by time. So electric power is what? Rate of which at which electric energy is dissipated or consumed in an electric circuit. Rate at which electric energy. We know that electric energies also can be replaced by work. So power equals to what? Electric energy by time, because it is a rate of electrical energy. Electric energy is what? Heat only. That we have written over here, H by T. And from Joule's law of heating, what we did now only, H equals to I square RT. So TT will be cancelled and P equals to what? I square R. Again I square R we can convert into we can break it like IR into I. What is IR over here? IR is V, that is voltage. So P equals to VI. Again B we can write IR, so it will be a form of I square by R also. Okay, there's a mistake in the last part. I have written by mistake over here that P equals to I square by R. Actually it will be V square by R. You just correct it later on in your copy, that I equals to V by R. You will put the value over there, I V by R into V, and it will come what? V square by R. If you are facing any problem over there, you can contact me. And what is unit of power? The unit of power is what? You can see over here, it is heat by time. And the unit of heat is what? Joule. The unit of time is what? Second. It will be what? Joule per second. And joule per second is known as what? Watt. W-A-T-T. So W-A-T-T is a unit of power. Again, if I tell you to define 1 watt, how you can define 1 watt of power? 1 watt is the power consumed by a device that carries a current of 1 ampere through a potential difference of 1 volt. I think this you already know, that how to define one of any unit. This we have done multiple times. Now 1 kilowatt, if I say, it will be what? 1000 watt. You know that meaning of kilo is what? 1000. From here we know that power equals to what? Heat by time, that is energy by time. So energy will be what? Energy will go to power into time. What is unit of energy? The unit of energy is joule. The unit of power is what? W. The unit is time of time is what? Second. So joule is equals to watt second. And if I say take bigger unit, the watt will be replaced by kilowatt and second will be replaced by hour. So it will be what? Kilowatt hour, which is a bigger unit of electrical energy, which is also known as 1 unit. This is only the practical unit of energy. So if I tell you what is the practical unit of energy, the practical unit of energy is 1 unit, it is known as 1 kilowatt hour. Now what is the difference relation between 1 kilowatt hour and joule? You can see over here that joule is what? Joule is watt second. So what we will do, we will convert that kilowatt hour into watt second. In 1 kilowatt there is 1000 watt. In 1 hour that is 3600 second. So it will be what? 36 into 10 to the power watt 5 watt second. If I place a decimal over there, it will be 3.6 into 10 to the power 6, and watt second is known as what? Watt second is joule. So in 1 kilowatt hour there is 3.6 into 10 to the power 6 joule. Now we will do again some numericals. As you can see in this circuit, there is a resistance of 4 ohm and there is an electrical bulb of 20 ohm, and they are connected in series, and find total resistance. And we know that they are in series resistance. So how to find the resistance of series? By simply adding the resistors. So we are adding over here. So RS will be equal to what? R1 plus R2, it is 4 plus 20 equals to 24 ohm. From there only we need to find the current now. So current equals to what? V by total resistance. V is what? 6 volt, given over there in the diagram only, and RS is what? RS equals to 24. So it will be equal to what? 0.25 ampere. For the same question, what is potential difference? Potential difference across the lamp. So potential difference across the lamp. You can see there is a lamp over there. What is the potential difference formula? V equals to IR. Current we have already found that current is what? Current how much? 0.25. What is the resistance through that? It is 20. So 0.25 into 20, that is 5 volt. Okay, potential difference across the conductor. So in this case the current will remain same, but we know that for the conductor the resistance is 4 ohm, so it is 0.25 into 4, that is 1 volt. So what is total potential difference? It is 5 plus 1 equal to 6 volt. Now here there is a question that R1, R2 and R3 are the three resistors of 5 ohm, 10 ohm and 30 ohm. They are connected in parallel and voltage is given 12 volt. Find the current through each resistor. We know that I1 equals to what? V by R1, I2 equals to what? V by R2 and I3 equals to V by R3. V, R1 and R2 and R3, everything is given. You just put the value and find the answer over there. Total current will be what? The sum of all the current I1 plus I2 plus I3. And what is total resistance? As it is parallel combination, we know that formula is what? 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3. We'll put all the values. 1 by Rp equals to what? 1 by 3. Therefore Rp equal to what? Rp equals to 3 ohm. Okay, now one more numerical problem is there. You can see that there are two resistors first over here which is connected in parallel. Again there are three resistors over here. This is connected in parallel. There is a voltage of 12 volt and there is an emitter over there. What you need to find? First find the total resistance. So first you can see over there that R1 and R2 is in parallel combination. We will find their resistance by 1 by Rp formula. Then we will see that R3, R4 and R5 also are in parallel combination. Again we will use that formula only and we will get the value of this also. But later on, just be careful over here. See the diagram. R1 and R2. In the next diagram, R1 and R2 is replaced by Rp and R3, R4 and R5 is replaced by Rp dash. Rp comes how much? 8 ohm after calculating, and Rp dash comes how much? 10 ohm after calculating. And voltage given how much? 12 volt. Now you see that Rp and Rp dash, you can see that you might be thinking that this is in parallel combination again, but no, this is what? This is a series combination. Now if you want to find the resistance, so from here you are going to add it simply, because this is going a continuous path and this is a series combination. So Rp and Rp dash is in series combination. One is 8 ohm and one is 10 ohm. So what will be the total resistance? It by adding we will get what? 18 ohm. After that we can find current by putting the value of voltage and resistance. Voltage was given 12 volt and resistance is came how much? 18 ohm. We are getting the current is 0.67 ampere. Now again there is a question. The numerical I have given over here. The electric iron is there. Maximum power is given 840 watt. Minimum power is given 360 watt. And voltage is given 220 volt. We need to find the resistance in both the cases, when the power is maximum and when the power is minimum. Suppose if power is maximum, P equals to 840 watt, then we know that the formula is what? P equals to VI. So what will be I over here? I will be P by V. That is, the current is what? 3.82 ampere. And what is from value of R? R equals to V by I. So V is given to 20 volt. Current we have already found over here. We can get the value of resistance. Similarly, you will do in the next part also, in which power is minimum. That is homework for you. Again here, you can see that heat is given 100 joule. Time is given each second, that is 1 second. Resistance is given 4 ohm. You need to find the voltage. So we have a formula that H equals to I square RT. From there, by putting all the values, we can find that current equals to 5 ampere. Therefore, V equals to what? V equals to I into R. Okay, R already given, and we have calculated over here. Just put the value and get the value of V. It will be 20 volt. Next question is what? V equal to 220 volt and I equals to 0.50 ampere. We need to find the power. So we know that power equals to what? V into I. We have been given B and I both. Just put the value, multiply it, and we'll get the power as 110 watt. This is perhaps the last question, I think. This is a question of refrigerator in which power is given 400 watt. It operates for 8 hours per day, and we need to find the total cost of the electricity for a month. So suppose if it is operating for 8 hours per day, how much time will be there for 1 month? 30 into 8, that is how much? 240 hour. Okay, we what formula we have? When we will find the total cost, we will find the energy in the kilowatt hour formula, not in joule. We'll find in kilowatt hour formula. So total energy is what? Power into time, but the power must be in kilowatt and time must be in hour. Okay, so here power is how much? 400 watt. We need to convert into kilowatt, so we are dividing it by 1000. So you can see over here that I have done power is what? 400 by 1000. Okay, again time was given how much? 8 hours per day, and there are how many days? There are 30 days, so 30 into 8 equals to what? So it is coming what? Kilowatt hour. So how many kilowatts hour there? 96 kilowatt hour. Means what? 96 minute, and the rate is given. The rate is rupee 3 per kilowatt hour. So it will be total cost will be how much? 96 into 3, that is rupee 288. This is the cost of the 1 month for that refrigerator. This was the last question of this chapter. After this I will give you a worksheet.